Greetings, everyone. My name is Chris Dieringer.
Hello, I'm Cory.
We're super excited to be here and talk to you. We only have 10 minutes, and this is very problematic because we could just talk all day about this. So we're going to hustle, but in that process, we're probably going to drop some things. So please, if we confuse you or forget to say something, just raise your hand because we don't want to leave you confused. With that, next, Cory.
How do you?
Yeah. So I'm Chris. That's Cory. Both guys, and we went to college together like a decade ago. That was a lot of fun. And we also used to work together at a brain research company. So we've just been hacking for a long time. We have good pair synergy. Pair programming. Okay, bloopers. Got them.
Yep.
The monster.
Growling.
Good. How about the hacks?
They're hacking in.
I did the rest. We're ready.
All right.
Okay, so Emily said we're here to talk to you about a donut generator. That's true, and we're going to, but that was really inspired by some prior work. The donut generator came out of a different project. Cory, tell us about it.
Yeah, so we worked at the Mind Research Network, which is a nonprofit. Can you hear me? Oh, there we go. Good, close. We worked at the Mind Research Network, which is a nonprofit neuroscience company, and we worked on this project called CoinStack, which attempted to solve some big problems in neuroscience data sharing. So the first problem is the constraints based on imaging data and sharing it. Researchers have to commit to maintaining participant privacy, and study facilitators oftentimes just don't allow file sharing. Because it's been shown that people can reverse engineer the images and derive personally identifiable information from them. So this kind of creates data silos, which is bad because that data, the neuroscience images, could be useful for many different projects.
Yeah, it's crazy. It's like, it's 2016, Obama says, everyone, you got to share your data if it's publicly funded, but we've got a bunch of brain imaging data and you can't share it. So another big problem is that brain imaging data is just huge. So oftentimes when you're doing brain scans, you don't take, one of the processes is you take just like hundreds and hundreds of photos of different slices of the brain. And then you do it from different perspectives too. So after you just take a series of scans on one participant in a research study, you might be looking at a gig to 2 gigs of data. And then you multiply that if you've got a couple hundred, a couple thousand people in your research study. You're looking at terabytes of data sometimes, and you just can't conveniently share it. So you could try to put it over the network, but it's slow. You got to pay for bandwidth. It's a problem. What still happens very regularly today in brain research is that people literally ship hard drives to each other. It's very archaic. It's pretty hilarious, and I feel bad for the lab tech who has to just like plug these things in all the time because they need to aggregate all the data to do research. Yeah. So what did we do? We came up with this really cool system. Again, it's called CoinStack. It essentially says you're not going to share data. All right, you're not going to share data. Rather than bringing the data to the analysis, we're going to bring the analysis to you. So if you've got data, I'm going to ship you an analysis, and you're going to run it there. I'm going to ship you an analysis, and you're going to run it there. And when we've all done our analyses, we kind of ship the metadata about those analyses up to the cloud, and we do an analysis over the analyses. This doesn't generally work with a lot of numerical methods in data science today, but we have some really expert machine learning wizards who are pretty bleeding edge. It's really cool. And then to make sure that evildoers can't somehow mythically, magically reverse engineer that data or the results of that data, we add a bunch of noise, terrible GIF, to make the data like completely obscure so no one could ever figure it out. So how do we do it, Cory?
How did we do it? We used JavaScript. We're JavaScript engineers, and so we made an application powered by Electron. It uses React and Redux in the front end, and it's powered by backend Node.js services using Pouch, Happy for a RESTful API, CouchDB, and then we roll our neuroscience algorithms into Docker containers to run them because they're written in Python.
We had some screenshots. I don't know why they're not rendering. Sorry.
I didn't have them.
That's fine. Yeah, so why are we here? We're here to show it to you, right? The real version's still in work by our old pal back at our last job. And it's a little more complicated. So we want to kind of give you a simpler version of it. Well, scientists are off answering really important questions like what factors lead to schizophrenia. We're answering a much, much more important question. What makes a donut super good? So we're going to give you a sneak peek into how the product generally works with a fun donut demo and talk about some of just a tiny little bit of machine learning on donuts.
Cool. So we made a web application, and you can see the URL there. There's also a QR code that points towards it.
Phones out, everybody. We need you to participate.
And this is, yeah, you can participate.
Please. It's going to be great. It's going to be great. You're going to love it if you're into donuts.
Let's see. How do I get to the? Is it?
Oh, it's just the second tab. Well, give him a sec. Give him a sec to look at the link.
Okay.
Yeah, I think the QR is being truncated
Oh.
on the bottom. You can. Yeah, it's just the URL. You can just go right there. This was for your convenience. We're very user-centric. We're front-end. JavaScript developers are crying out loud. I don't even know how to. I don't have a QR app. Got it? Is everyone seeing it? All right. We've got people doing it. Cory, you're driving, man. This is you.
How do you? Oh, there we go.
Apparently, I already have some donuts saved, but this is you.
Oh, what am I talking about here? Let's see. Oh, cool. So I guess I'm going to talk a little bit about the web app that we made. So let me see if I can get to the. Oh no! How do I get to the? Let's see. We made
the cursor is terrible. Just got to use your mouse, buddy. Use your mouse.
Where is it? I don't see it.
I'll do it. Here, I got this. Yeah, the screen. You'd think that the screen would be on the correct side. There you go. Woohoo!
All right, cool. So we kind of asked ourselves, like, how do you visualize a donut? Well, what is a donut? It's composed of basic shapes. It has sprinkles, which are these little pill shapes, and then it has a bunch of concentric circles. And we thought, well, like, what in the browser is like good at making shapes and manipulating them? SVG is. It's great. So we made our. Let me see if I can get to the sliders here. Sorry, reverse. We made the donut out of SVG, and it's this is a React app, so it's just a component. Everything's a component, and you can kind of control the aspects of the donut using these sliders. And don't worry about the faces right now, but yeah.
Yeah, ignore these emojis. You should make some donuts that like match your own heart's content, and make sure to save them.
I can't see.
That's okay. Let's go back to the prize.
Cool.
So tinker around with that for a minute. I'm just going to continue talking here. All right, but we're not just making donuts, we're learning about donuts. So a big part of our app here is a false objective to discover the worldly phenomenon that explains what really makes a donut delicious. It's a contrived problem. But data science, right? So you guys are making all these donuts, and we're going to have you submit them to us momentarily. And we have a series of systems in our backend that are going to ingest your donuts and then predict what the ideal donut is. Our services we haven't cheated or anything. They have no idea. But when you're doing data science, there's a lot of, you generally have an objective, right? You take data as input, and you want to come to some conclusion on the output. One of the strategies that you can do in data science is just kind of a classic regression. Regression says, give me your data, and from that data, I will give you a function that explains the data. So, and this is kind of a real simple case. You can imagine that all these troughs and peaks are actual donut data points. The more donuts that you give the regression, the better it's going to be able to actually create a mathematical formula that well fits the data. And so we're going to do some learning together to predict the world's most delicious donut. It's going to be great. All right. Cory, launch the hacks. Actually, I use Colmac keyboard, and Cory can't type on my laptop. Don't do this on your machine.
Please don't do this.
We've got this. You have to enable hack mode.
Hack mode totally enabled.
And we have an admin mode. This is Cory's stuff.
Great. So I'm going to. Oh man, how do you? God,
Yeah, I know this.
can't
We
even
didn't.
use your mouse.
We thought this thing was going to be a little further up.
Cool. So we have this thing called the donut monster, which sort of accepts all your donuts. So if you go to the donut view, you should see an upload button. And I'll go ahead and try to go to the. Oh gosh, where is it? I can't.
I'll do it. I'm a great clicking guy. I'm really good at clicking. All right. So these are donuts that you are submitting.
This is all happening via the magic of Socket.io. So your donuts are going to our little Node.js server, and that's passing them off to a Docker container containing.
Yeah. So as your donuts are coming in, we're taking those, we're piping them into a series of Docker containers. Oh yeah, it was teeny. It's kind of like little pips.
Look at the little one.
Those little pips donuts. And we use a Python stack for machine learning. Everyone in machine learning uses Python because apparently data scientists think Python's fast. Really, tangent. It's Fortran that makes Python fast in machine learning because Fortran has all of the low-level bindings for linear algebra, which matrix math is what exploits all the characteristics on your CPU that make it fast. And those bindings exist in JavaScript too. Anyway. Yeah, so we do, the first thing we do is we take your donuts and we make a model. We try to make an equation, right? We try to make an equation that explains what makes your donut delicious. Once we've got that mathematical model, we run another process that kind of explores, it kind of walks those peaks and troughs of that mathematical formula, and it tries to find a maximum. When it finds a maximum, it says, aha, that's the best scoring donut. I know what characteristics make that donut really delicious, like coverage and thickness and radius. And I send it back to Cory, and he paints it into his totally sweet animation. We're using two different machine learning techniques. We're using a ridge regression here and KNN. I'm not going to go into what those are because, again, 10 minutes. Yeah, those are literally your donuts. This actually learned pretty. Hey, Cory, you scroll down a little bit.
Can I? Can I
I
scroll
don't know.
down?
Can you scroll down? You know how mine's scrolling
there we go.
backwards.
Yeah.
This learned actually really quick. When we did this, we ran a bunch of tests. This usually took, like a minute. But right now, the KNN's scoring pretty high. It can predict, the perfect donut is score 1. And it's guessing something that's 0.94. So this is pretty close to the ideal donut. You can see this method is kind of struggling. We actually built show them the fire hose.
Yeah.
Usually it takes a lot more data, but I guess you guys are more even. You've created a bunch of more evenly distributed, diverse donuts than we did. We're kind of donut bigots, if you will. And so Cory made this totally rad thing that just generates a ton of random donuts, and it just spits them at the screen. We limit how many donuts go on the screen at once, though, for
It's like 10 a
performance
second
reasons.
or something, yeah.
All of the sprinkles are individual DOM nodes, and when you have like 10 gazillion DOM nodes in the browser, it really shuts down.
Basically, I have to use Chrome.
Yeah.
Yeah.
That was a lot. Yeah, we just talked about that. Next. What's our time? Someone have time? Cool.
You want to show the bloopers?
Yeah.
All right.
So we have some bloopers. Geometry is fun. But geometry is also hard. Oh, damn it. This is going to work way better. Oh, thanks. Here's some. Oh, yeah, this will be red. Hey, thanks, man. So we probably have 20 of these. We're not going to go through all of them. But we just screwed up placing sprinkles on donuts or sizing the sprinkles. Some of them are pretty hilarious. That one's pretty straightforward. It's kind of fun. This one was kind of interesting. It kind of looks like a bunch of buzzing bees. Yeah, they should fire us now. Oh, this one's amazing. This was actually not a bug. This worked. We had to make sure that the sprinkles are evenly distributed, not spaced too close to the inner radius, not spaced too close to the outer radius. Whatever. Whoops. Fixed it.
I think this one's
That
my
one's kind of
favorite.
it's kind of beautiful. This one's really interesting because what you're observing is not quite randomness. There's a lot of trigonometry. Obviously, we're converting. The DOM works in rectilinear coordinates. You have an x and a y. But when you position sprinkles on a donut, you have to convert to polar coordinates. And in that conversion, you're using a lot of sine and cosine. And what seemed to be randomness actually showed some interesting patterns. Donut bloopers. So great. Oh no! That one was great. We got to see it. We got to go look at that one. Pretty fun. These are all on our website. You guys can go and make donuts all you want in the future. It's all open source. We'll give you the link at the end. We're probably going to turn off the donut machine learner thing, but whatever. Plugs.
Let's see, plugs. Math. We're plugging math, I guess. We use Cleaver for the slideshow. It's this really great tool. It's no configuration. You just pass it a markdown file and it spits out a slideshow. What else? I can't remember that.
Docker, it's cool. Yeah, those are our plugs. If anyone's used Docker Road, the Node.js bindings into Docker, good luck. It's great, but it's hard. Questions? What? Salsa? Oh, yeah. No, salsa the condiment. Seniorsalsa.org. There's also a plug. Yeah, I love salsa. I lived in New Mexico for a year, so I got some intense salsa vibes. She's just putting her shirt on. That wasn't a raised hand. Dang it. Going once, going twice. Thank you.
Thanks.